Hello and welcome to this video where I'll be showing you some of my deep sky images together with my own running commentary. Let's begin. If you look up at the night sky from any large city, you will see only a few handfuls of the brightest stars. But if you happen to be out in the countryside under a very dark sky, you may see thousands of stars with your naked eye. But even then, most people don't realize that if only our eyes were sensitive enough, the sky would be full of beautiful objects in fantastic colors. Through the almost magic-like phenomenon of digital photography and long-time exposure through our telescopes, we can explore the wonders of the heavens, such as the Horsehead Nebula seen here under the leftmost star of Orion's belt. The Horsehead, though seemingly small, is a vast cloud of dark dust silhouetted against a backdrop of red glowing hydrogen gas. Hydrogen is the most common element in the universe, and in ionized form it is responsible for most of the red colors found in the interstellar clouds. Oxygen, which glows blue-green, is also common as seen here in the Heart Nebula, where it blends with hydrogen in the central parts of the cloud to produce an almost white glow. In the densest part of the darker areas of the cloud, dust and gas concentrates under its own gravity, and new stars, complete with planetary systems, form when the pressure and temperature gets high enough to start fusion of hydrogen to helium in their cores. These vast clouds of gas and dust produce clusters of stars, some small and dim, shining mostly in the orange, red and infrared, and some shining brightly in white, blue and ultraviolet light. The energetic radiation from these bright stars are responsible for making the interstellar gases glow. This nebula, the Orion Nebula, also contains a lot of dust which is reflecting the light from the stars in front of it. The energy produced by the fusion process makes the stars shine, and the light pressure starts hollowing out the cloud and eventually blowing the gas away to stop the star-building process, and leaving a naked cluster of stars, a so-called open cluster. Open clusters comes in all sizes. Numbers of around 1,000 stars are typical. The Beehive Cluster, also known as the manger, why is anybody's guess, is around that size. In this image, the colors of the stars have been exaggerated a bit, which is a tendency with many astrophotographers. We like to make pretty pictures. Larger clusters, like Caroline's Rose Cluster, which is named in honor of British astronomer Caroline Herschel, was discovered by her in 1782. It consists of more than 1,000 stars, which are loosely bound to each other by gravitation. But the stars, though formed from the same cloud of gas, are on slightly different orbits around the galaxy's center, and over time, on the scale of several millions of years, the stars may drift apart and spread out through the galaxy. Our star, the Sun, was once part of an open cluster, but its siblings are now so far apart that none have been identified with certainty, though the search is on. If you look up at the sky in the winter part of the year, you may find the Pleiades, the Seven Sisters, which is another open cluster only 450 light-years away. It is so close to us that our unaided eye can resolve a few of the brightest stars, hence its name. If we observe it through a telescope, we find that it consists of more than 1,000 stars with a slight haze surrounding the brightest members. The digital camera reveals it in all its splendor. The stars are embedded in clouds of interstellar dust, a so-called reflection nebula, which is scattering their light in the blue part of the spectrum. These dust clouds are not originally part of the cluster. The stars merely happen to pass through the nebula on their way around the galaxy. For the casual observer, the heavens seem unchanging, but stars are not eternal. The most massive stars are also the hottest and brightest, but they can burn through their nuclear fuel in as little as a few 100,000 years. When they end their existence, they go out with a bang, an extremely violent explosion, a so-called supernova, which can be as bright as the combined light from all the rest of the stars in the galaxy. The explosion throws the outer part of the star out into space, leaving the exposed core of the star as a white dwarf in the center. The white dwarf star is very small and dense, only about the size of planet Earth, but it is extremely hot and shines brightly in the ultraviolet part of the spectrum. The Cygnus loop seen here is the remnant of such a supernova explosion. It is the ultraviolet light from the central white dwarf that makes the gases glow in the red and blue-green. The globular clusters are a mysterious breed of star cluster which orbit around the center of the galaxy. Some of the orbits are highly inclined to the galaxy's disk and brings the clusters far outside the plane of the Milky Way. Other galaxies have them as well, but despite being studied intensely, there is still much mystery as to their origin. The great Hercules cluster consists of more than 100,000 stars in elliptical orbits around their common gravitational center. There's very little going on in terms of star formation, as there is very little dust and gas present in the cluster, so all the stars have approximately the same age. Some hot blue stars called blue stragglers, though seeming young, are believed to be the result of the recent merging of smaller stars. Outside the realm of the globular clusters, we come to intergalactic space, where vast distances, millions of light years, separate the individual galaxies. The nearest large spiral galaxy is the Andromeda Galaxy, or M31, which in many ways resemble our own galaxy, the Milky Way. It contains somewhere between 200 and 300 billion stars. Estimates vary. M31 is only about 2.5 million light-years distant and is the furthest and largest object that can be seen with the naked eye, though only under a very dark sky. M31 is orbited by a large number of globular clusters, which unfortunately are too small to be resolved by my little telescope. What we can see, though, is a couple of orbiting dwarf galaxies, M32 and M110. The combined system is on a collision course with the Milky Way, which it will reach in 4 to 5 billion years' time. Galaxy collisions are a common phenomenon and usually result in the galaxies merging into one larger galaxy. This process can be studied in this image of M51, the Whirlpool Galaxy, which is actually two galaxies caught in the act in mid-collision. The stars in the galaxies seldom collide, as the interstellar distances are very large compared to the size of the stars. Galaxies are mostly empty space, but the stars' orbits are very much influenced by the enormous gravitational fields of the merging objects. This can be seen in this image as large streams of stars which has been pulled out of the two galaxies, which even seem to be connected by one of the spiral arms. The collision has stripped the smaller galaxy of most of its interstellar gas, causing star formation to stop. In the larger galaxy, the gravitational turmoil plus the added gas and dust from the smaller companion has caused star formation to run amok, making the spiral arms blue in color due to the many hot young stars. Another nearby galaxy is the Triangulum Galaxy, or M33, which has a very different appearance than M31. Though it is also a spiral shape, its disk and spiral arms seems to be composed of clouds of stars, somewhat resembling lamb's wool, which is why that type of galaxy is sometimes called flocculent, from their tufty look. The last galaxy image I will show you is of M106, yet another spiral galaxy with a rather peculiar look. It looks almost like someone has hit it with a very large hammer, causing it to warp slightly. The outer spiral arms and the inner disk seems to be at an angle to each other. This is possibly also caused by some gravitational influence in its past, maybe a near collision with another galaxy. Whatever the cause, it looks very beautiful. I'm going to end this video closer to home with a little video of Comet C2022 E3 ZTF, which I shot in January 2023 when it passed through the inner solar system and was visible in the northern sky. Comets are leftovers from the time when the solar system was created, and they contain large quantities of frozen gases and water ice which evaporate when they get close to the warm sun. The light from the sun blows the gases away from the mountain-sized orbiting piles of rubble, creating the well-known comet tails. That's it for now, but since you're still with us, I hope you've enjoyed this little presentation of some of my deep sky images, and if you liked what you saw, please click the like button and subscribe to my channel if you want to see more astronomy-related material in the future. Bye!